Okay, so today in Algebra 2, we're going to look at the last part of section 3.7. I'm going to pick up in the notes that says identify a transformation. So yesterday we looked at graphing transformations and what that looked like. And now we're going to write the equation of the transformation given the graph. So number one, determine the equation of the graph as it relates to its parent cubic or quartic function. So I know all of these are either going to be x cubed or x to the fourth. Okay, a transformation off of that. So number one, this is the graph they give me. I notice that my end behavior is an up, down. So that tells me that I'm going to have negative coefficient and odd exponent. So right now I know I'm looking at a negative x cubed function. So remember that from yesterday when we learned to graph them, that our x cubic had a turning point, the parent function had a turning point at 0, 0. So I just have to identify where is that turning point on this graph. It's this point right here. So 0, 0, 0, 0 on this graph became the point negative 3, negative 1. Again, using all of our rules for transformations that we already know. So negative 3, so it went left 3, so the graph went left 3 and down 1. So to write the equation, f of x is equal to, we set up here, we knew it was a negative, so negative in parentheses. It's a negative 3, so it always goes in parentheses opposite, x plus 3, quantity cubed, and then down 1 minus 1. That's the equation of the transformation of f of x equals x cubed that's represented in this graph. All right, let's look at number 2. I can see my end behavior is going the same way, right? So I know it's an even. So my end behavior, I've got a down, down. So that tells me it's a negative and an even. Since they told me that we were looking at either cubics or quartics, I know that right now I'm looking at negative x to the fourth. Again, yesterday we learned graphing in x to the fourth that the vertex is at 0, 0. So now I want to see where's my new vertex at. This point right here is now at 1, 5. So that tells me that the graph went right 1 and up 5. And then I also know that it's opening down, right? We said that it was negative. So my equation, f of x, is equal to negative, parentheses, right 1, so that was an x minus 1 in parentheses, quantity fourth plus 5. There's the equation of this graph that they gave to me. Let's look at number 3. You can tell by looking at it that it's going to be a cubic, right? My end behavior is an up, down. So again, I know that that was a negative and an odd. So I know I'm looking at a negative x cubed transformation. The turning point went from 0, 0 to what on this graph? So here's my turning point, which is at 2, 4. Therefore, I know that this graph is x cubed that went right 2 and up 4. And then we also said that we knew that it was a negative. So my equation, f of x equals negative, parentheses, x minus 2, quantity cubed, plus 4. There we go. We're going to do one more of those. So our last example of this, by looking at it, I see my end behavior is up, up. So I know that this was a positive and an even. And since they tell me that they were either quartics or cubics, I know that this is an x to the fourth. So again, on x to the fourth, I looked at my vertex. How did it move from 0, 0? It is now at the point negative 1, negative 4. So that means it went left. Sorry, that's not a negative 4. That is a negative 3. I know that it went left 1 and down 3. So my equation, f of x, is equal to, in parentheses, x plus 1, quantity to the fourth, all of that minus 3. All right, so now we're going to look at applying transformations of a cubic function. Okay. So it tells me that the volume of a box in cubic yards is given by the function v of x equals x cubed. The post office lists permissible shipping volumes in cubic feet. We want to write a function for the volume in cubic feet if x is the edge length in yards. So basically we need to convert yards to feet. Okay. So they told me that this is in yards and I want to put it in feet. So convert yards to feet. Well, I know that there are 3 feet in 1 yard. Okay, that's the conversion. So I need to take x and replace it. They told me that this was in yards, so my x now needs to become 3x. I want the volume of 3x. So I'm going to rewrite this equation that they give to me. I'm going to replace the x with 3x. So instead of x, I'm going to put 3x and then quantity cubed. So then the volume of 3x is equal to, so now 3 cubed is 27x cubed. So this would give me the equation of the volume in cubic feet instead of cubic yards. Okay. The next one, a terrarium is in the shape of a rectangular prism. The volume of the tank is given by v of x equals x times 2x times x plus 5, which is equal to 2 times x cubed plus 10x squared, where x is measured in inches. The manufacturer wants to compare the volume of this tank with one that has a width 2 inches shorter but maintains the relationships between the width and the other dimensions. Write a new function for the volume of the smaller tank. So 2 inches shorter. So I'm looking for v of x minus 2. So I'm going to replace all of my x's with x minus 2. So, and I'm going to use this, a factored form of it. So that first one, instead of x, I'm going to write x minus 2. The next one I have 2 times x, so I'm going to pull that 2 on the outside and put x minus 2, and then I'll distribute my 2. And then instead of x, I'm going to put x minus 2 and then plus 5 there. So I've just replaced all of my x's with x minus 2. Now I'm ready to simplify this and make it look pretty. So here I have x minus 2. I'm going to distribute this 2, and so I get 2x minus 4. And then combine like terms here, and so I get x plus 3. So now I just need to FOIL these first 2 together. So x times 2x gets me 2x squared minus 4x plus 8 times x plus 3. I'm going to go ahead and combine like terms here. So I've got 2x squared minus 8x plus 8. And I'm going to distribute that or multiply that with x plus 3. So when we do that, we get 2x cubed plus 6x squared minus 8x squared minus 24x plus 8x plus 24. And so now I just need to combine like terms. So I have v of x minus 2 is equal to 2x cubed. Let's see, minus 2x squared minus 16x plus 24. So notice here, we're just writing the equations. We're not really solving anything. They're just asking us to write equations. All right. We're going to look at a few more examples doing the same thing. So turn the notes over. The volume of a cube in cubic feet is given by the function v of x equals x cubed. Write a function for the volume of the cube in cubic inches. If x is the length, the edge length in feet. So I need to change from feet to inches. So I know that 1 foot is equal to 12 inches. So x now becomes 12x. So I want v of 12x. So this equation, replace x with 12x, and I get 12x quantity cubed. So v of 12x equals, so 12 cubed is 1,728 x cubed. That would be our new formula. All right, one last problem. A storage unit is in the shape of a rectangular prism. The volume of the storage unit is given by V of x equals x times x minus 1 equals x cubed minus x squared, where x is measured in feet. A potential customer wants to compare the volume of the storage unit with that of another storage unit that is 1 foot larger in every dimension. Write a function for the volume of this larger unit. So again, all we're doing is writing the equation, changing that equation up. So instead of V of x, we want V of x plus 1 because they want it to be 1 foot larger. And again, I'm going to go back to where it was already factored. I'm going to replace all of my x's with x plus 1. So I get x plus 1, x plus 1, x plus 1 minus 1. Okay. So now I want to work this out. X plus 1 times x plus 1, that's like x plus 1 quantity squared. I can use my shortcut. So I know my shortcut says the first one squared. Multiply the two together and double it. So x times 1 doubled gives me plus 2x, and the last one squared plus 1. All of that times, when I simplify this last one, the ones cancel each other out. I'm just left with x. So v of x plus 1, now all I have to do is distribute my x. I get x cubed plus 2x squared plus x. That is my new function of the volume. All right, homework assignment today is 3.7 worksheet, numbers 17 through 24. You can find the worksheet under the announcements or under the assignments. You will do the work on your own sheet of paper. Label your paper 3.7, numbers 17 through 24. Show your work, and tomorrow I will collect that. We will be taking our test on Thursday, so remember our test that covers sections 3.5 to 3.7, along with the performance assessment that can cover anything from chapter 3, will be this Thursday. So tomorrow we will also look at a test review.